This is kind of a continuing of part two. Basically, improve productivity creates a greater access of data across the supply chain network, and real-time data operates the manufacturing result what to know and when you need to know, and supplies what is needed to reduce waste and downtime. Innovation with higher quality products save money, which can be invested in product development of a higher quality. So with that, we want to know a little bit about more jobs. Adapting some smart buildings, smart manufacturing is a way to attract more tech-savvy workforce, because the traditional piece of it is a little bit more difficult to kind of hold on to more techy stuff. So utilizing some of the data apps, we can recognize some new opportunity. And then energy efficiency, where manufacturers can then reduce some of the carbon footprint, reduce energy and energy intensive industries, so that it gains more energy savings. This not only reduce energy waste but also make product more affordable because of this. Yeah. So paradigm of manufacturing is five common trends that we can see. The shift of more labor intensive to a more advanced technology based process. So the ambiguity role of information technology, relying on the modeling and the simulation in the manufacturing processes, is actually much better in hand, and acceleration of innovation in global supply chain management, moving towards a more changeability of manufacturing in response to the customer's need and external impediments, accepting the supports and sustainable manufacturing. So all these are some of the five common trends that's shifting from more labor intensive to more advanced technology based processes. Okay. So want to introduce some interesting words which call Industrial 4.0 is a revolution of cyber physics systems, sometimes called a CPS, towards the end of the supply chain, IIoT, Industrial Internet of Things, decentralized intelligence in manufacturing, production, logistics, and industry, utilizing cloud computing and connective computing. So Industrial 4.0 is some digital transformation. It makes the market with the smart manufacturing currently on forefront, and then 4.0 is commonly referenced of the industrial revolution, right? So 4.0 also represent the fourth industrial revolution in terms of more discrete and process manufacturing. Discrete will means that it's pretty on and off, meaning it's more focused. It also and helps to the logistics supply chain and the chemical industry, energy utilization, transportation, oil and gas, mining, and metal itself. So we'll now share a little bit about the first industrial revolution. In sometime in 1760s to 1840s, Britain introduced some machines which actually moved the machine into production at the end of sometime in the 18th century. So steam power engines is kind of invented, and then that moved from production to the end to include some manual production from a steam power engine. So this is the start of the first industrial revolution. So as you can see, the first industrial revolution talks a little bit about mechanical production moving from the cottage industry. So before that, it's still very farming based. So industrial 2.0 is moving to electricity, where there is a mass production in the assembly line, right? So as you can see, some of the primary means of production has moved from steam power to electrical power. One of the key things is like a train. So used to be a steam engine, now has become an electrical train as the source of power. So it's much higher power ability to move more, better, stronger, and more powerful. So electrification of factories contribute significantly to the production rate, so driving the product cost down. So the production of steel, railways, and the goods move faster and faster between different places, since you enhance the mass production. Then you come to industrial 3.0. So Industrial 3.0 is also called the third industrial revolution, often refers as the digital revolution, brought by the change of analog to mechanical systems to digital systems. So sometime between in 1950s to 1970s, there's also called information age. The industrial revolution is still a direct significance of development in computers, information and communication technologies. So basically, Industrial 3.0, we have changed it to a more electronics. So coming to this age right now is a fourth industrial revolution. It takes into a new level of introducing some customization of a flexible mass production, and machines can then operate independently, cooperate with human in creating the customers orientated production that is consistent maintenance itself. So it's made possible by introduction of self-optimization, self-coordinations and self-customization. What it means is basically is able to kind of redesign itself, very personalized in a way. And then the term Industrial 4.0 was first introduced in Germany and was launched a project called Industry 4.0. Digital manufacturing at Hannover Messe, and of course, representing including government, official, industrial leaders, academics were working on it and enhance the German competitiveness in the manufacturing industries. So it's converging from IT in the industrial internet to OT or some operational technology and autonomous machines through big data analytics, digital ambiguity, cloud, smart factory, and also learning in AI, cyber, physical space. So the impact of COVID-19, right, which is about 2 years or 3 years ago, actually helps to make this acceleration in order to prepare for digital with low carbon economy. The industry remains competitive as well as decarbonizing. That we must directly move towards a bigger society of change, like net zero emission economy, and of course including inclusive of growth, health, social recognition, sustainable mobility, and of course mobile environmental generations. So in addition to the developments of Industry 4.0, Industrial 5.0 refers to the people working alongside with smart robots and machines. So basically the robots is to help human works better, faster, leveraging advanced technology like IoT and big data. So a lot of portion of machine learning becomes part of it. So it's a human touch for industrial pillars of automation and efficiency. So Industrial 5.0 talks about human-robot collaboration and connective systems and customization. So some of the benefits, there are many benefits in 4.0, but not all relevant. Somehow 4.0 in practice means for many different things, and some consider the Industrial 4.0 and other would not be. But in general, the trend of automation, data exchange, cyber system, industrial internet of things, computing and connective computing creates kind of a smart factory. So 5 reasons why is it relevant to important is these current challenges for the manufacturers with the market volatility, shorter life cycle, higher products complexity, global supply chain. Company needs to be faster, flexible, response to business trend. The digital of the entire product will then allow the use of data exchange in production services, social media to make the product faster, cheaper in terms of improvement. So companies can then reach out to faster demand, implementing some new configuration easier to replan for much faster changes. So the other piece is Industrial 4.0 also lead to innovation economy. Digital change will not only improve efficiency but also speed up innovation as business model and implementing much faster. To do example how we can speed up innovation, manufacturer can generate new business by sharing equipment and selling capacity they do not need in the market. So with sensor connectivity, with enriched services such as predictive maintenance, even transfer into service, the engine manufacturer could not sell engines anymore, but it provides services to customers, and then it charges the power of the engines the customers use. So a lot of time, like chill water as a service is also part of what it's going to put on. Number three, it puts customers in the center of activity. So customers now becomes like individual that make product and services personalized. So in smart item, product, machines enable manufacturer to get down to a one lot size. It produce one, unlike like Industrial 2.0 is mass production. Now the production is like one piece. And the other part is also digitalization will lead to easier cloud sourcing and faster design processes.